In this video, we are going to talk about similar polygons. Okay, last section, 5.1, we talked about similar triangles. Similar polygons are the exact same, except now they're just not triangles. Like, similar polygons still have the same shape, but different size. Okay? The corresponding angles are still congruent, and the corresponding sides are still proportional. Okay? Remember, congruent is represented with an equal sign and a tilde, and proportional is represented with a colon. And proportional means that we have the same common ratio like we talked about in 5.1. Okay? So, if the quadrilaterals below are similar, then what must be true? Well, we see angle A and angle E both have one arch mark, which means about the angles, angle A is congruent to angle E, and we match all of our arch marks. So angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. What does that mean about our sides? Well, our sides have to be proportional when polygons are similar. So we have segment AB, which is between the 1 and the 2 arch mark, is proportional to segment EF, which is also between the 1 and the 2 arch mark. Segment BC is proportional to FG, segment FG. Segment CD is proportional to segment GH. And segment DA is proportional to segment HE. And so the sides are proportional and the angles are congruent. Okay. In example 2 down here, it asks us what is the common ratio. So we're looking at the sides when we're trying to figure out common ratio of quad EFGH, so the EFGH quad, to ABC, which means that this quad has to come before this guy. Okay? So again, we take our short side and our two short sides, and we make our fractions. So we have what looks like to be 2.5, because I need EFGH on top and ABCD on bottom. Okay, so my shortest side over here is 5. When I simplify that, it becomes a 1:2 ratio. If I go to the next side, so next short side would be 3/6, which is 1:2. Then we have 4/8, which is 1:2. And then we have 5/10, which is 1:2. So my common ratio is 1:2 in regards to quad EFGH to quad ABCD, which means for every 1 unit I have in this polygon, I should have 2 units in this polygon. Okay, I'm going to turn the page and keep going. Example 3 here shows that I have X, Z, 8, and 12. I also have on ABCD. And I have EF, GH, and I have Y. So I have some missing pieces. So I need to figure out the common ratio so that I can figure out the missing pieces. Well, I can't use, if we look here, first we can match things. So it says quad ABCD first. So I need to have the correct quad in order. Well, A has 1 arch mark, so I need 1 arch mark over here, which would be E. Then 2, which is F, then 3, which is G, and then 4, which is H. So now I have my quads in order, and my similarity statement is made, so I can find the common ratio. Well, the top sides that correspond I have a missing piece, so I can't use those. These left sides here I can't use to find common ratio because they're also got a missing piece. I can't use the bottom because it's missing. So I have to use the right. And because I know they're similar, because this guy tells me they're similar, I already know that they're all going to have the same common ratio. And since they have the same common ratio, I only have to find it once. So I can do 3 over 12. 12 over 3, because this triangle comes, or not triangle, polygon comes first. So this guy comes first and this guy, so I should have A, B, C, D over E, F, G, H, which means that I have 12 over 3, which is equal to 4 over 1. So for every 4 that I have here, I should have 1 here, okay? Which means that I could take these and multiply by 4 to get the other side. So for x, I have x over 6 is equal to 4 over 1. And you see I'm going to cross multiply to get my answer, which gives me 24 is equal to x. So x equals 24. For my y, I have 8 over y is equal to 4 over 1. I get 8 and 4y. 4y is equal to 8, which means y is equal to 2. Common ratio is 4:1. Okay? For z, I have z over 1 is equal to 4 over 1. When I cross multiply, I get z is equal to 4. And that is how you do that. You set up, you find your common ratio, and you make your other fraction and cross multiply. Down here, in example 4, it wants us to answer the questions. It said quad TSRU. So this quad came first, which means this one is second. We see T is here, which means that it needs to match the same angle, which it's obtuse. So we can say that it matches the obtuse angle of P. Then we said S, which is the acute angle up here, which means it matches N, so PN. Then R and M have the same angle, and then U and Q are both our blanks left over. So we have our similarity statement now where we matched our angles. So we can again find the common ratio. So we're looking for the common ratio. We see that the ST, which is the first two letters, and our PN, which are the first two letters, there's an X there, so I can't do that one. We see that we have TU, which is Y. TU matches PQ, which is 15, but I can't use that because of the Y. We have a number on SR, which is 30, so SR is the two middle, which is NM, which is 18. So I could say that TSRU over PNMQ is equal to 30 over 18, which if I simplify that, I get 10 over 6, which can simplify even more to 5 over 3. So my common ratio is 5 to 3, which means now I can go and find X and Y. Well, again, I need TSRU over PNMQ. So for X, TSRU would be 25 over X is equal to 5 over 3. I can cross multiply and get 5X is equal to 75. When I divide by 5, X equals 15. I do the same thing for Y. So Y, again, we have Y over TSRU. This is TU, so I need to match first and third, which is PQ, which is 15, is equal to 5 over 3. I cross multiply, and I get 3Y is equal to 15 times 5. Right over here, 3Y is equal to 15 times 5, which is 5 carry the 2, 75. So Y is equal to 25. And that is how we find x and y using our cross multiplication in order to solve various things. And that is how we do similar polygons.